Hey everyone! Welcome back to the channel. Today, we are going to build a completely procedural, dynamic condensation effect in Blender using geometry nodes. As you can see, these water droplets don't just sit on the glass, they actually react dynamically to an external object. When our proximity control sphere moves closer, the droplets smoothly disappear, creating a gorgeous interactive look that is perfect for product commercials, VFX, or abstract art. Best of all, this setup is entirely non-destructive, and you can apply it to any mesh instantly. Let's start completely from scratch and dive straight in. First, let's clear our workspace. Press A to select everything in your default scene, the cube, the camera, and the light, and press X to delete them. We want a completely blank canvas to work with. To get a high-quality model for this effect, we are going to use the Blender Kit add-on. If you don't have it enabled, you can quickly activate it in your preferences under Add-ons. Go to the Blender Kit search bar at the top of your viewport, filter your search to Models, and type in Bottle. Browse through the free models until you find a clean, realistic glass water bottle or soda bottle. Once you find one you like, simply click it to import it directly into the center of your scene. With our bottle selected and centered, let's head over to the Geometry Nodes workspace at the top of Blender. Click New in the middle of the graph editor to create a fresh node tree. Let's rename this modifier in the panel to something clean, like Condensation Effect, so our project stays organized. Right now, we just have our standard group input and group output nodes. To scatter droplets across the surface, we need to generate points. Press Shift+A, search for a Distribute Points on Faces node, and drop it right onto the geometry line connecting the two groups. The solid bottle disappears, replaced by a cloud of points. Don't worry, that's exactly what we want for now. Let's turn up the density value to around 250 so we have a thick, lush layout of points covering the entire silhouette of our bottle. To bring our original bottle mesh back into the viewport alongside these new points, let's search for a Join Geometry node. Connect the original geometry from the group input into the Join Geometry node, and then connect our scattered points into it as well. Now, let's set up the magic ingredient, the proximity control. Go back to your 3D viewport, add a simple UV sphere, scale it down slightly, and pull it off to the side. This sphere will act as our dynamic controller. To let geometry nodes talk to this sphere, simply click and drag the sphere from your outliner window directly down into your node graph. This instantly creates an Object Info node for us. Crucial tip here, make sure to switch the drop-down on this Object Info node from Original to Relative. If you skip this step, Blender won't track the sphere's real-time movement correctly when we move or animate it later. Next, let's search for a Geometry Proximity node. Take the geometry output from our sphere's Object Info node and plug it directly into the target input of the Geometry Proximity node. Set the calculation mode to Faces. This node is now constantly calculating the exact distance between our control sphere and every single point on our bottle. The raw distance numbers from the proximity node can be a bit unpredictable, so we need to normalize them. Search for a map range node. Take the distance output from our proximity node and plug it straight into the value slot of the map range node. Let's tweak the behavior. We want the droplets to completely vanish when the sphere gets close. To do that, change the from max value to 0.5. This controls the fall-off radius. Then, flip the output targets. Set to min to 0.0 and to max to 1.0. Now we need something to actually render as our droplets. Search for an instance on Points node and place it right after your Distribute Points node. Now for the magic connection. Take the result output of your map range node and plug it directly into the selection input of the Distribute Points on Faces node. By plugging this straight into the selection, Blender will dynamically hide the points wherever our control sphere gets close, giving us total control over where the condensation appears. Add a UV sphere node and connect it to the Instance input. Then add a random value node connected to the Scale input. As you can see, our effect is working perfectly, and look just how incredibly satisfying that looks. You can definitely use this setup to create a ton of cool animations. But now, it's time to take things to the next level and build the actual reveal effect. Now, select your bottle and change the to max value of the map range node to 1.6. As you can see, this completely covers the entire bottle. To create the reveal, we just need to animate our proximity controller sphere moving from the bottom to the top. Let's add our keyframes, set the animation interpolation to Bezier for a smooth transition, and just like that, we are good to go. Now, it's time to assign a material to our droplets. Search for a set material node and drop it right between the UV sphere and the instance on points node. This allows us to assign a beautiful liquid shader directly to the instance geometry. Our effect is now completely done. Next, I'll set up some basic lighting. I'm going to fast forward through this part just to save you some time. By the way, if you run into any issues building this node tree yourself, the complete project file is available for download in the description below.